So the first chapter from the Year 12 course fairly much just deals with revision from Year 11. It starts with factorization techniques. So the ones that you should be familiar with are difference of two squares, perfect cubes, sum and difference of two cubes, the cross method, and completing the square. The quadratic formula is just a derivation from completing the square. So we will start with a few different examples and get ourselves familiar with those again. So we'll just use this one that I've got here. So this is just a simple quadratic. X squared here has a coefficient. So we would either use the cross method here or we'd use completing the square if we can't take out a common factor. So we can take out one common factor, and that would be 2. So we take the 2 out the front. Which leaves us with 3x squared plus 8x plus 4. Now, if you remember from the cross method, the next thing to do is to find two factors of 3x squared. So they will have to be 3x and x. Sometimes if we had a different number there, say for instance we had something like 10, then we'd have several different combinations that we could use. But for 3, because it's a prime number, we only have 3 and 1. So we use 3 and x. So we need two numbers which multiply to give us 4 next. So they could be 1 and 4 or 2 and 2. But what we need to do is when we cross these over, we need to get a sum that adds up to 8x. So if we try 2 and 2 to begin with, and we cross. So what we do is we cross multiply x with the 2, and we get 2x. Cross multiply 3x with 2, and we get 6x. When we add those together, we get 8x. Just double checking. So if we multiply these two, we get 3x squared. Multiply these two, we get 4. So we have our 3x squared, our 8x, and our 4, which means that this here is a factor and this here is a factor. Now they were positive 2's. So our factors become 3x plus 2 and x plus 2. So 6x squared plus 16x plus 8 can be factorized as 3x plus 2, x plus 2. So a really simple example to start off with. So before you launch into any more complicated techniques, you should just try straight away to find out whether we can do this by trial and error, which means we need to look for two numbers which multiply to give negative 14 and add to give negative 5. So numbers which multiply to give 14 are 1 and 4 and 7 and 2. We need to get negative 14, so one of those has to be negative. If we want to get negative 5, when we add the two together, it'll be negative 7 times 2 gives us negative 14, and negative 7 plus 2 gives us negative 5. So if we factorize that, x squared minus 5x minus 14, that's going to be x minus 7, x plus 2. Second example, so if you look through that little laminated card that I gave you that has factorizing techniques on it, you should recognize that this one straight away is a perfect square. It's so when we have a look at it, we should be able, the first step we should do is actually write each of these as squared terms. So the first term here, 9a squared, is in fact 3a squared, because 3 squared gives us 9. And the final term is in fact 4b squared, because 4 squared gives us 16. And if we have a look at the coefficient here of AB, so the coefficient is minus 24, which is in fact, minus 24 is 2 times 3 times 4. So minus 2, we can write that instead of minus 24, AB, we can write that as minus 2 times 3a times 4b. Now if we have a look on our expanding and factorization little card that I gave you, you should notice that that's very similar to one of the perfect square laws. So it's similar to a squared minus 2ab plus b squared is equal to a minus b all squared. So instead of a, we have 3a, and instead of b, we have 4b. So when we factorize our quadratic, instead of a here, we're going to have 3a, and instead of b here, we're going to have 4b. Okay, so we'll do an example where we should probably use completing the square. First things first, we should note that there's a common factor here, common factor of 2, so we're going to take that out the front. Now we could trial and error some factors of 7, so because it's a prime number, they're only going to be 7 and 1, but no matter how we arrange that, we can't use 7 and 1. Minus 7 plus 1 is going to give us minus 6. Positive 7 minus 1 is going to give us positive 6. So that's not going to get us 4 in any way. So we should see straight away that we should probably use completing the square. You could, if you've remembered to take out the common factor, you could use the quadratic formula. But we'll start with completing the square. So to complete the square, we take the coefficient of the t term, which is this 4, halve it, and then square it. So in other words, we've got 2 squared, which gives us back 4. And then we take it away, and we add it and take it away. So what we've got here is becomes, don't forget our 2 out the front, t squared plus 4t, and we add the 4, and then we subtract the 4. So the first part of our expression we should recognize as being a perfect square. T plus 2 all squared. And we have minus 11. Now we use the difference of 2 squares. Because we can write this as the square root of 11 squared. Difference of 2 squares, t plus 2 plus the square root of 11, t plus 2 minus the square root of 11. So as I said, you could do it using the quadratic formula, but you would have to make sure that you'd taken out this common factor first. If you didn't do that, you might run into some problems. So quadratic formula, minus b plus or minus the square root of b squared minus 4ac over 2a. Remember, that's x equals. So substituting into the values, we're taking the values from this expression. So a is 1, b is 4, and c is minus 7. So minus b gives us minus 4. Now don't forget, we need to simplify the third. So that third, square root of 44 is actually 4 times 11. Square root of 4 is 2. We can now divide through top and bottom by 2 because 4 divides by 2, 2 divides by 2, and 2 divides by 2. So that just becomes minus 2 plus or minus square root of 11. So when we write our factors, we won't have a negative, we'll have a positive because, of course, we've got if x equals negative 2, then that means that our factors have to be plus 2 plus 11 and plus 2 minus 11, square root of 11, sorry. So it's the same, oops, and I don't forget my 2 out the front, so that we have the same factorization as we did using completing the square. It might be easier when you do these questions to use completing the square, because if you forget to take out that common factor, you won't get the right solution. So there are a couple of examples in your textbook that are fairly good. They're on page 5 of the textbook. So if you want to go through them, I'll do a couple in the screencast in case you can't follow them in the textbook. So the first example I'll do is a perfect cube. So it's example A from page 5. As I said, it's a perfect cube, so you should recognize that 27 is 3 cubed. So we can write this as 3y cubed, this first term. The second term is 3 times 9 is 27, and 9 is 3 squared, so we can write 3 times 3 squared, whoops, I had it as 3 times 3y squared. The third term, we can write that as 3 times 3y. And the minus 1, let's write that as 1 squared. 1 cubed, sorry. So if we have a look at our perfect cube rules, it's shaping up to look like the second one, which is a cubed minus 3ab plus 3ab squared minus b cubed. So if we have a look here, our b is in fact just a 1. So it could actually be here, it's just not written. We could actually have 3 times 3y squared times 1 and 3 times 3y times 1 here. So our b is in fact a 1 and our a is in fact a 3y. So when we factorize it, it just becomes 3y minus 1 cubed. Do that in a second. So the second one I'll do is C. You can read B and D yourselves. They're similar to these two examples that I'm just doing now. Before you do anything, you should note that there's a common factor here of 3. So you would take 3 out the front. Again, you should notice that 27 is a cubed number. It's 3 cubed. And what we have now is the difference of 2 cubes. So again, the rule from that little laminated sheet that I gave you. Our A is a Y and our B is a 3. So we make those substitutions into this expression. And 3 squared is 9. Sorry, I just realised that should have been a plus there. So it should have been y squared plus 3y minus plus 9. Okay, so what I want you to do is stop and give yourself a go at questions 1, 2, 3, and 4 from the first exercise, exercise 1.2.